the G here. So this is the one special case for combinational logic design. And for logic design, we have to always think about one critical parameter, and that critical parameter is that time. So how to build a first circuit, and for that time consideration, we have to take care about the delay. Delay is in between input change to the output change, meaning that let's have a look at a very simple and very fast logic circuit, which is the buffer. A buffer here which is single input A and one output Y, A and the output Y. Whenever A is 0, Y is also 0. A is 1, Y is equal to 1. But whenever A changes from 0 to 1, then Y is also changed from 0 to 1. Whenever A changes from 1 to 0, Y is also changed from 1 to 0. But the 0 to 1 here and 0 to 1 here, definitely it will take some time here. That time is that time, and this is called the delay. This is called the delay here. And this delay should be minimum as possible. Okay, so there is two types of delay. One is called propagation delay, and second one is called the contamination delay. One is called propagation delay, second one is called the contamination delay. Propagation delay here is that maximum time, how long, maximum delay taken from the input to the output. That's called the propagation delay. And the contamination delay is the minimum delay from the input to the output. So let's have a look at the same example here, same buffer circuit here. This one is a buffer which is a single input A and the output Y, and this A is here changing from 1 to 0, or it can be changed from 0 to 1. So there is two delay, and this is Y. Y is also changed from 1 to 0 and also changed from 0 to 1 here. So here you can have a look here. From this state change 0 to 1 or 0 to 1 or 1 to 0, the propagation delay is that when the final output Y is stable, and the contamination delay is that starting of change in A from 0 to 1 or from 1 to 0, there will be a change in the output, started a change in the output from 0 to 1 or 1 to 0. That is the minimum delay for change, starting of that change, and this delay is called the contamination delay. And this total delay for the stable output is called the propagation delay. So propagation delay is the total delay for the stable output. Contamination delay is that delay where the change of output is started. Basically, this contamination delay is very important for multi-input circuit, and normally the RC time constant is the main cause for this delay. So the capacitance C or the resistance R in a circuit is the creating this kind of RC time constant delay. Also the speed of light limitation cause this kind of delay, and normally the propagation delay is a bit high than that of the contamination delay. Why? For the different rising and falling delay, rising edge delay and falling edge delay, and you will have the multiple input and output, some of which are faster, some of them are not faster. So for this kind of fast change of input and output, there will be some kind of difference between the propagation delay and the contamination delay, and the circuit will slow down when it is hot, and the circuit will be speed up when it is cool. So it is that if the power dissipation is very high, then it will be a bit hot. During that time circuit, the RC time constant will be a bit high, which will cause a bit more delay, and when it is cold, the RC time constant, or the speed up is a bit slow. So this is in short the combinational logic design or combinational logic circuit for computer hardware. So thank you very much.